Hi everyone, my name is Ghita El Boukili. I'm a PhD student at Al University. As you can see on the screen, our topic today is entitled Improving the Rheological Properties of Bensmim clay for its use in clay brick production. This work is carried out within the scope of the Africa-Europe Bioclimatic Buildings for the 21st Century project.
Obviously, clay was and still the prime construction material through the ages. As we all know, using clay on construction has a lot of benefits. It's a recyclable and energy-saving material with a good thermal properties. In Morocco, clay is an abundant raw material with a variety of structures and compositions. Unfortunately, its exploitation is considered poor and insufficient. Consequently, the Moroccan government imports clay products from other countries such as Spain and Italy. For example, Bensmim is a mountainous region in the Middle Atlas situated near Ifrane city. This isolated poor village is desperate for affordable housing with decent thermal properties. The cheap, the natural, and the affordable raw material in this region is clay. Unfortunately, this clay was found to be not suitable as a raw material for the clay brick industry if it's used in its raw state because of its weak plasticity. So the objective of this study, and in the perspective of a sustainable development of the region, this study aims to improve the properties of this unexploited clay and make it suitable in the clay brick production. The exploitation of local clay resource of this region in the production of building materials have many beneficial impacts. Clay-based materials will be produced locally with similar features and lower cost than the imported ones. The cost and carbon footprint of material transportation is also minimized. Now, let's talk about the used material in this study. We used Bensmim clay extracted from Bensmim region and Extrabrick clay recovered from a brick manufactory named Extrabrick and located in Meknes city. This clay was used as a reference in this study because it produced good clay bricks with good performance and good properties. And finally, bentonite clay. This clay was used as an additive in this study. The first step in our study is the raw material characterization. We performed XRD diffraction and the grain size distribution test. We also performed Atterberg limits of our three samples. From all the conducted tests, we can say that, the weak plasticity of Bensmim sample is related to its low clay fraction, the absence of expandable or swollen clays, the dominance of quartz. However, Extrabrick sample is considered as plastic clay because of its large clay content and the presence of swollen clay. From all this, we can conclude that, or we can suggest that the addition of bentonite clay to Bensmim sample can improve the plasticity and thus it will also improve its performance.
So now let's move to the next part, which is the rheological measurements. Different suspensions were prepared using different percentage of bentonite, as you can see on the table, and the tests were performed using NCR rheometer from Anton Par and following three steps as you can see on the screen.
The obtained flow curve shows that all samples show the same behavior. The first zone is characterized by a yield stress, which correspond to an elastic deformation of the sample, and then the second zone correspond to a quick fluidization resulting from the succession of bonds ruptures and deformation of particle aggregate. The last zone, delimited by an inflection point of the flow curve, correspond to shear thinning behavior of the inert particles. The addition of bentonite to Bensmim clay strongly affects the rheological behavior of suspensions. It increases plasticity and thixotropy, making Bensmim soils behavior closer than the reference sample. On the other hand, we can see that the viscosity of all studied suspensions decreased with increasing shear rates and we can say that it became steady at higher shear rates. We can notice also that the addition of bentonite increases the viscosity of Bensmim sample, makes it close to the reference sample, which is Extrabrick sample. This could be explained by the inner properties of bentonite clays, known by their high plasticity and ability to form a strong network structure, which is also called jelly structures. These interactions increase the cohesion of particles and thus the flow is slow. Now let's sum up. We found that the weak properties of Bensmim clay is related to the microstructure and the mineral composition of raw materials. Bensmim clay is non-plastic clay because of its sandy composition and the absence of swelling clay in its mineral composition. So we found that the addition of bentonite up to 9% improves its composition and thus its rheological behavior, making our sample's property close to the reference sample. Thank you.